So I'm not going to be able to give you an answer to why magnets attract each other, except to tell you that they do, and to tell you that that's one of the elements in the world of the different kinds of forces. There are electrical forces, magnetic forces, gravitational forces, and others, and those are some of the parts. If you were a student, you'd go further. I could go further. I could tell you that the magnetic forces are related to the electrical forces very intimately, that our relationship between the gravity forces and electrical forces remains unknown, and so on. But I really can't do a good job, any job, of explaining magnetic force in terms of something else that you're more familiar with, because I don't understand it in terms of anything else that you're more familiar with.
Consider direct current running through a wire. If you put a stationary electron next to this wire, nothing happens because the wire is neutral. However, if the electron moves along the wire, there's a force acting on it. Let's say the electron is moving with the same velocity as electrons in the wire. Then, from the point of view of our electron, the electrons in the wire are stationary and the positive ions in the wire are moving in the opposite direction. Thanks to Einstein, we know that movement results in space contraction. The positive ions seem denser than electrons, so our electron feels attracted to them. If our electron is moving with the opposite velocity, then, from its point of view, both electrons and the positive ions move, although electrons move faster. Both electrons and the positive ions undergo space contraction, but for electrons it is stronger. Electrons seem denser than positive ions, and our electron feels net repulsion. If we have two wires with the currents running in the same direction, then an electron in one wire feels attracted to the other wire because it perceives positive ions in that wire to be denser than electrons. As a result, the two wires attract each other. For currents running in the opposite directions, an electron in one wire is repelled by the other wire because it perceives electrons in that wire to be denser than positive ions. As a result, the two wires repel each other. Similar effects occur if the wires are slightly deformed. But what happens if we make a loop of each wire? Let's stack two loops on top of each other and run the currents in the same direction. Like in straight wires, the moving electrons look at the closest part of the other wire and perceive positive ions to be denser than electrons. As a result, the two loops attract. If the currents run in the opposite directions, the loops repel. However, if we put two loops next to each other and run the currents in the same direction, the situation changes. Now, in the closest parts of the wires, the currents run in the opposite directions, causing the loops to repel. Similarly, if the currents run in the opposite directions, the adjacent parts of the loops have the currents running in the same direction, so the loops attract each other. A magnet behaves like a loop of wire with a current in it. Every magnet is made of many little loops of current. There are two types of them. Electron has a spin, so it can be treated as a tiny loop. Electron orbits around the nuclei can also be treated as loops. Usually, the most of magnetic field is generated by the spin of electrons, and electron orbits have smaller contributions. But keep in mind that these are very rough approximations, and actual behavior of electrons is described accurately only by quantum mechanics. Quantum mechanics also explains the behavior of different substances when exposed to a magnetic field. In some materials, we can align the loop so that the material becomes a permanent magnet. Permanent magnets attract iron because magnetic field turns a piece of iron into a magnet temporarily. Finally, some materials don't allow their loops to be aligned, so they respond to magnetic field very weakly. Now you know that magnetic force between wires with currents is explained by electric force and special relativity. A magnet behaves like a loop of wire with a current because it is made of many little loops of current. And properties of these loops are explained by quantum mechanics. Okay, but here's a question for you. If an electron moves perpendicular to a current in a wire, why is there a sideways force acting on it? Or in other words, why does a railgun work?